Here we're going to look at solving exponential equations using logarithms. Alright, our first step would be to isolate the exponential expression. So what that means is we want to get the base and its exponent and some number on the other side. So in other words, we want to isolate, get by itself the base and the exponent. We don't want to have anything in front of the base or beside the base or beside the exponent. We just want base exponent equals a number on the other side. When we solve exponential equations, the variable, if you look down here, the variable that we're solving for is actually trapped in the exponent. So we want to free it from the exponent. The only way to do that is actually to apply a log. So I'm going to cross this out, and I'm going to ask us to all do the same thing. I'm going to ask us to take the natural logarithm of both sides of the equation. So I'm just going to ignore the rest of those words. We're going to take the natural log of both sides. So step 1, isolate the exponential expression. Step 2, apply a natural log. We're going to simplify using a log property, and then we're going to solve for the variable. Alright, our first example, 4 to the x power is equal to 15. Step 1 would be to isolate the exponential expression. So in other words, step 1, we want exponential form. So I want to have the base with the exponent equals some number on the other side. And that is exactly what we have. The base is 4. The exponent is x, and then we have this number on the other side. So this is actually fitting into exactly the form that we want. So step 1 is done. Okay, step 2 is to apply a natural log to both sides. So we have 4x equals 15. I'm going to give myself a little room there. So I'm going to take the equation that I have that's in exponential form, and I'm going to apply natural log to both sides. So I have to apply natural log to everything I see. So it's ln of the left and ln of the right. So on both sides of the equal sign, I have to write ln. I have to put everything on the left side in parentheses to become the input for that log, and everything on the right side also has to become input for that one log on the right side. Our next step is to apply a log property. Typically, that log property is the power rule. Now, the power rule says that if everything inside of a log is raised to exactly the same power, then I'm allowed to bring that power out to the front of the log. So that becomes x times natural log of 4 is equal to the natural log of 15. Step 4, we want to solve for the variable. So solving for x, we want to get x by itself. So what that means then is I want to get rid of anything that's beside x. X times the natural log of 4, I want to get rid of the natural log of 4. Well, we're going to undo the operation that connects x to the natural log of 4. So we're going to do division. We're going to divide by exactly the thing we want to get rid of. So we're going to divide by the natural log of 4. So our final answer is x equals natural log of 15 divided by the natural log of 4. Now for exponential equations, we're not required to check our solution, but we can if we want, but we're not required. What we end up with is an exact solution, and we would also like to get the approximation. So to get the approximation, it's an R. To get the approximation, we're going to go and use Desmos, or any calculator that you have, but I'm just going to pop up Desmos. It's important that you have 15 in a log by itself at the top and 4 in its own log by itself at the bottom. Okay, so when we go to type into Desmos, we'll make sure those two things are separate. So I'm going to go to Desmos, desmos.com. I'm going to click on Start Graphing. And I'm going to go to the keyboard. I'm going to go to the keyboard here. Nope. Sorry. This keyboard on Desmos. And I'm going to go to Functions. And I'm going to click on... Stop. I'm going to click on Miscellaneous. We're going to go to Natural Log. And I'm going to type in 15. Now, it's important here that you don't try to do divided by 4 right now. You want to make sure that you come out of this log. So you notice that my little cursor is outside of the parentheses. Then we're going to tap divided by. And then we're going to type in another function. So we'll type in function, ln again, and then type in the 4. So our approximation is shown here. So we have 2 different ln functions with 15 only in the top and ln of 4, the 4 only in the bottom. So 2 different ln's with a division between those ln's. So our approximation, if I'm rounding to the nearest 2 decimal places, is 1.95 approximately. Alright, let's look at this example. So here, what's really important, I'm going to put a couple of stars by this one, and you might have one like this in my math lab. What's really important is to know that this one, the exponent is 3x. The only thing that is actually the base is the e. So I'm going to write that here. The base is e. The exponent is 3x. The 2 is not part of the base. Really important. 2 is not part of the base. The biggest mistake that gets made with these types of problems is to leave the 2 there. Okay, that's the biggest mistake I see. You need to know that anytime you see e, that you need to get rid of anything that's in front of e. Super important. Okay, otherwise, really frustrating to solve. When you go into my math lab and you see an exponential equation where e is in the problem, you need to get rid of any number that's beside e. So we want to get rid of the 2. So the first step is to get this in exponential form. You need to get rid of the 2. How is the 2 connected to the e? The 2 is connected to the e by multiplication. So we're going to divide both sides by 2. Alright, so any time that you see e in the problem, you need to get anything that's in front of e or beside e to go away. Let's actually do this division here. 762 divided by 2 is actually 381. So let's go ahead and write that as 381. Okay, so really important. Any number in front of e, you need to get rid of it. In this case, we wanted to divide to get rid of the 2. The biggest mistake that I see when we're solving these problems is that people go in and they go ln of this. And they just apply ln to both sides. Okay? No. No. Okay? You have to get rid of any number that's with e first before you can start applying the natural log. Okay? So now we have e by itself, and that's what we want. E, that's the base. 3x is the exponent, equals, and then we have a number on the other side. So now we are actually in exponential form. Step 2, we want to apply ln to both sides. Alright, so now we have e to the 3x power is equal to 381. Give myself a little room there. And we're going to apply the natural log parentheses. So ln parentheses around everything that's on the left, ln parentheses around everything that's on the right. Okay, step 3 is we're going to use a log property. Okay, now in this case, what do we know about natural log and e? ln is a log with a base of e. If the base of the log and the base of the input match, then they cancel each other out. So that's a nice little log property there. Leaves us with just the 3x. Now the natural log does not disappear on the right side because we don't have a log property that allows us to cancel out the ln with 381. Step 4. Solve for x. We want to get x by itself on one side. Alright, now we have 3 times x, so I'm going to divide both sides by 3. I get x is equal to the natural log of 381. Now it's important to know that the natural log of 381 is all by itself. The 3 is not inside ln, so it's not inside the log. So our final answer here, exact answer, is the natural log of 381 divided by 3. Let's say that I wanted to get an approximation. If I wanted to get approximately what that number is, we can go back to Desmos. Type in natural log. I'll just start over so we can see what we did. We want the function. We want natural log. I'm going to type in 381. Now remember, you want to come outside of the log, so I'm going to hit this arrow here to come outside of the log. And then I'm going to hit divided by. So you want to make sure that this 3 that we're about to type in is not inside of the log. So type in 3. So we get approximately about 1.98. Okay, about 1.98 is our approximation.